Hello. Now we'll talk about priority scheduling algorithm. This algorithm is available in two modes, preemptive as well as non-preemptive. Priority non-preemptive scheduling is a CPU scheduling algorithm in which each process is assigned a priority and CPU is allocated to the process with the highest priority. Now, if say priority is given number as 0, 1, 2, 3, 4, or maybe 1, 2, 3, 4, then 1 is said to be highest priority job, 2 is said to be lower than the 1, then 3 is said to be lower than the 2, which is in subsequently lower than 1, kind of. However, once a process starts executing, it cannot be interrupted until it's complete, even if a higher priority process arrives. So we will take one example and we'll understand how exactly it works. So let us say we have been given five processes P0, P1, P2, P3, P4 with their respective arrival time and burst time. Now, let us say we have been given priorities as 2, 1, 3, 2, 1 respectively for P0, P1, P2, P3, P4. Now, as this is a non-preemptive job, so at arrival time, look at 0, we don't see any job available with low priority, and it is a non-preemptive job. So ultimately, when it is a non-preemptive job, it will continue its execution. So P0 starts at 0, finishes its execution at 5. Then, like as we see that the timeline reached to 5, ultimately now all processes have arrived, considering the arrival times. So now, according to the priority, like we have two jobs with one priority, and respectively one job is there for, or one process is there for priority 2 and one process is there for priority 3. So with respect to the priority 1, FCFS would be applied. So ultimately P0, then P1, then P4, then P3, then P2 would be executed. So appropriately, their completion time would be like for P0, it would be 5. For P1, it would be 8. For P2, it would be 26. For P3, it would be 18. And for P4, it is 12. Now, we have to compute turnaround time for this priority scheduling non-preemptive algorithm. So, like we know that to compute turnaround time, we subtract arrival time from completion time. So we get a turnaround time for P0 to be 5. For P1, it would be 7. For P2, it would be 24. For P3, it would be 15. And for P4, it would be 8. If we sum up this, then like would be getting 59 divided by 5 number of process to compute average turnaround time. So it will give us 11.8 as a turnaround time, average turnaround time. Now let us start to compute waiting time. So as we are using the same Gantt chart which we have drawn. So now for P0, when process P0 arrived, okay, it arrived at 0. It was given CPU that time only. So waiting time would be 0. Now all processes are arrived. Now P1 arrived at 1, but as P0 was completing, so P1 waited for 4 time units. P2 arrived at 2, but started execution at 18. So that's why like its waiting time would be 16. For P3, which arrived at 3, but given CPU at 12. So for P3, the waiting time would be 9. And subsequently for P4, P4 arrived at 4, but got CPU access at 8. So that's why waiting time is 4. So if we sum all these, then we would be getting 0 plus 4 plus 16 plus 9 plus 4, which results to 33 divided by 5. So we get 6.6. So this is average waiting time. And that's how this non-preemptive scheduling algorithm works.